All right, let's take a look at an example of one of these conformational analysis. So in this case, the question is asking us to draw the lowest energy conformer. And here's our compound right here. And we want to go ahead and look down this bond right here, right? This will be our bond of interest, right? So draw the lowest energy conformer of this. First thing we want to do is just start off by drawing our Newman projection, right? So we've got this carbon in the front. And if we think about it, there'll be a hydrogen to the kind of top left, a CH3 to the top right, and then another CH3 down here. And then we'll take a look at the back carbon that's being eclipsed. If we think about going straight up, it's an ethyl group. And so we can just write ET for ethyl. We don't have to write CH2, CH3. And then if we think about the bottom left, it's a hydrogen. And then the bottom right is a CH3. And so there's some good things about this conformer and some not so good things about this conformer. The first thing we can notice is that our kind of big things, this ethyl and this methyl group, are anti to one another. So that's good right there. However, this ethyl group and this CH3 group are gauche to one another. These two CH3 groups are gauche to one another. And then these two CH2 groups are also gauche to one another. So let's see, by rotating this back carbon a bit, can we lessen some of these gauche interactions? And so remember, always just rotate one of the carbons. I generally rotate the back one, but you don't, it's not a hard, fast rule. You can rotate the front one if you really want to. I would just suggest not rotating both of them because you're going to increase your chances of messing up, right? So there's our front carbon, and then the back carbon will just rotate. So now this CH3 will be over here. This ET will be over here. And then this hydrogen will be over here. And so we can see here that we still have our ethyl anti to one of these CH3s. So same thing over there. We still have one gauche interaction between this ethyl and this methyl, and still one gauche interaction between these two methyl groups. However, now we've got a better interaction here, right? We've got this CH3H, whereas before this CH3 was wedged between two big groups. And so this one on the right is actually lower in energy because there are less gauche interactions. If you think about the gauche interactions, right, there's one over here, 1, 2, 3 gauche interactions, whereas this one over here only has 1, 2 gauche interactions, right? So we've lessened it by 1 gauche interaction. And then we could continue rotating if we want, but if you think about rotating this ethyl group, you're gonna make it gauche to 2 methyl groups, right? So you're putting the biggest things gauche to 2 other big things. That's not a good thing to do. And then finally, the last thing that you wanna make sure is that you're only rotating these compounds, right? You have to rotate these. You can't just arbitrarily move them around and about because you may change the identity of the compound. So for example, maybe you're thinking that you can form this. Right, I'll put this ethyl group kind of over there, this methyl group over here. And then this hydrogen over here, right? Maybe that's about the same as the other one. You can't just arbitrarily move them around. And the reason for this, we'll see right here. If you think about redrawing the Lewis structure for this one, right? We've got this front carbon that has a carbon going down, right? So this is the bond that we're looking down. And then we've got this bottom carbon down here. We've got a wedge for the CH3. And then a dash for the H. And then if we go back to the back carbon, we've got a CH3 going into the back of the board, and then this ethyl group going into the front of the board. And so if we think about what our original structure is, right, what you'll see over here in this original structure is both of these methyls are wedges, right? We've got 2 wedges here. This one has a wedge and a dash. these are actually different molecules, right? And so by just arbitrarily moving these groups around, you can change the molecule, which obviously you can't do in real life. And so that would not be an acceptable answer. So what you want to do is just start by drawing whatever conformer it is in, and then just go ahead and take one of these groups and rotate them as needed. But don't just arbitrarily move these around. We'll learn more about this when we get to the stereochemistry phase. And so this one in the middle is the lowest in energy. If you're thinking about the highest in energy, that would be the biggest things eclipsing one another.